Welcome to Crypto 101, a first principles jargon-free course on blockchain and its impact on financial services. We will begin this lesson by looking at forks more comprehensively. We will discuss the meaning of forks. We were introduced to soft forks earlier. After completing the discussion on forks, we will learn about the meaning of the term Layer 2 solutions. Forks can be hard or soft. Hard forks refer to a permanent divergence in the rules of a blockchain network as applied by participating nodes, resulting in the creation of a new blockchain network. Soft forks refer to temporary divergence between nodes of a blockchain. Next, we will explore these concepts further. In a hard fork, some of the nodes on a blockchain switch to a new blockchain that is powered by rules that are different from the legacy blockchain. Next, we will illustrate a hard fork with an example. Consider a situation where 5 blocks have been mined on blockchain A. Its native currency is called alpha. Some nodes are not happy with how blockchain A works. Perhaps they want a bigger block size and faster confirmation times. So, they modify the original software of blockchain A and create a different network called blockchain B, with its native currency beta. In blockchain A, the next block mined will be block 6. In blockchain B, the next block mined will be the genesis block. The genesis block of blockchain B is mined with the rules of the new blockchain. Consider a node operator on blockchain A who has 100 coins of alpha and an address on blockchain A. As an incentive to switch his computer to run the software of beta, the new blockchain issues him 100 coins of beta at a 1-to-1 exchange rate. So now, the node operator has 100 coins of alpha held at an address on blockchain A. In addition, he also has 100 coins of pre-mined beta held at an address on blockchain B. Does this mean that the economic value of the node operator's holding has magically doubled? Not really. The market price of a new untested cryptocurrency like beta is likely to be much lower than alpha. And if the new blockchain does not take off, then the value of beta may very well be zero. We can now review examples of hard forks. Litecoin was started in October 2011. Its source was Bitcoin. The promoters of Litecoin wanted a faster transaction confirmation speed and a mining algorithm that is fairer to retail individual miners. Bitcoin Cash was created in 2017 as another fork of Bitcoin. Promoters of Bitcoin Cash wanted a larger block size so that more transactions could get confirmed in every block. Ethereum Classic was created in 2016 as a hard fork of Ethereum. The reason was that an Ethereum account got hacked of millions of Ether. A majority of the Ethereum community agreed to restore the hacked account to its original Ether balance. A minority of Ethereum nodes believed this was contrary to the spirit of immutability of the blockchain. Hence, Ethereum Classic became a separate blockchain. Strictly speaking, the Ethereum blockchain is the hard fork and Ethereum Classic is the original. But since Ethereum Classic is much smaller, that is referred to as the fork. The term altcoin refers to any cryptocurrency that is not Bitcoin. We can thus group currencies into 4 groups. One is Bitcoin, the original cryptocurrency. The second category are altcoins that are native currency of blockchains that were created as hard forks. The third category are altcoins that are native currency of completely new public blockchains. Ether is an example. While the first 3 relate to public blockchains, the fourth category pertains to native currencies of private blockchains. Many of the private blockchain platforms don't have a native cryptocurrency. We will talk about this further later in this course when we discuss the source of intrinsic value of cryptocurrency. The use of the term hard fork indicates that there must be something called a soft fork. While hard fork represents a permanent deviation between nodes of a blockchain, a soft fork refers to a temporary deviation. We have encountered soft forks earlier in the course. Next, we will learn the more expansive meaning of the term soft fork. There are 2 types of soft fork: data-based soft forks and code-based soft forks. Next, we will look at each one. Data-based soft forks arise when different nodes of the blockchain have different data records. We earlier saw an example of this when alternative views of the blockchain arose because of 2 blocks being at the same height. Because of network latency, different nodes received one of the 2 blocks first. Such forks are resolved through algorithms like the longest chain rule. Code-based soft forks arise when different nodes carry a different version of the blockchain software for a short period of time. A common example of soft forks in our daily life are app updates on our smartphone or update to the operating system of our phone. Eventually, when using the old version of an app results in loss of functionality, the laggards are forced to upgrade. Code-based forks are an efficient way to make blockchain network software updates that are backward compatible. Imagine if a network increases the maximum permissible size of blocks to 1 MB to 2 MB. Those who didn't upgrade can continue to mine blocks, but they won't have the additional functionality of mining larger blocks. This is an example of a change that is backward compatible. Layer 2 solutions are technology solutions that work in conjunction with a blockchain network with the goal of increasing the scalability of that network. To understand this definition, it is necessary to explain what scalability means within the context of blockchains. Consider a blockchain network with only 4 nodes. A transaction is created in node 1. The transaction must be propagated to each of the 4 nodes. Each of the 4 nodes must authenticate the transaction. Then one of the nodes proposes a block. Then the block is verified by every node. We can now expand this to 10,000 plus nodes of the Bitcoin network. For 10,000 plus computers to know every transaction that is occurring continuously creates a lot of latency. Every transaction and every block must flow to every computer and wait its turn to get processed. Scalability of a blockchain network can be defined as the ability to process a large volume of transactions at fast speeds at a low cost. Notice the trifecta of large volume, fast speeds and low costs. Let us now ask the question: what would happen if millions of payments started flowing into the Bitcoin network, comparable to Visa and MasterCard networks? Will it be economical to pay for a Starbucks coffee using the Bitcoin blockchain network? We can view transactions as customers in a department store and the nodes as cashiers. For a given number of nodes, say 10,000, if you increase the transaction volume by 10x, there will be increased latency in the network. First, transactions will take longer to be authenticated. Second, it will take longer for transactions to be included in a block for a given block size and block creation time. Even if we make the block size unlimited and the block creation time shorter, the transaction authentication wait time will remain. The other problem will be with the size of data being stored on the chain. As transaction volume increases, data storage costs become high and only a few centralized miners can afford to run nodes and mining operations. That would not be a desirable state since blockchain security relies on a large number of miners and validators acting independently and without collusion. Layer 2 solutions are technology solutions that work in conjunction with the blockchain network with the goal of increasing the scalability of the platform. Layer 2 solutions are a vast topic and learning about all of them is outside the scope of this lesson. However, to get a feel for what they are, we will look at a couple of examples. In this lesson, we will cover Polygon, which is a Layer 2 solution for Ethereum. In the next lesson, we will cover the Bitcoin Lightning Network. Polygon is a blockchain which is designed to be compatible with Ethereum. Developers can use the same tools to write smart contracts for Polygon as for Ethereum. A user can get an address on the Polygon network via a wallet the same way they can get an Ethereum address. Processing transactions on Polygon is cheaper than processing on Ethereum because it is more centralized. There are far fewer nodes that validate transactions on Polygon as compared to Ethereum. Ethereum and Polygon are connected by a bridge. Ether, ERC20 tokens and NFTs held on the Ethereum blockchain can be transferred to Polygon and back. We have not covered ERC20 and NFTs in this course yet. For now, all we need to know is that they are tokens on Ethereum similar to Ether but used for different purpose. Next, we will perform an actual transfer between Ethereum and Polygon. Before we process the transfer, I will open my MetaMask wallet. MetaMask is a non-custodial wallet similar to Exodus, which we reviewed earlier. I will now add Polygon network to MetaMask, so that the wallet can hold private keys of any address I acquire on Polygon. Let us give a minute for the process to play out. I will now go back to MetaMask and see whether I have any assets on the Polygon network. I switch to the Polygon network. I see that I don't have any assets held by my Polygon address. This is what I would expect. Matic is the native currency of the Polygon network. In other words, it is the equivalent of Ether and Bitcoin within the Polygon blockchain. Next, I will transfer some of my Ether to the Polygon network. To execute the transfer, I click on Bridge. I have to specify the destination network. I can see many other Ethereum-compatible networks. I choose Polygon. I then select the asset I want to transfer. I choose Ether. I input the amount which I wish to transfer. Note that I am paying more in gas fees to the Ethereum network than the amount of the asset being transferred. This obviously would not make sense in real life. But right now we are only trying to learn how Polygon works. I can see that this bridge process will take about 20 minutes. We will let the transfer go through and go back to MetaMask to review the outcome. I go back to MetaMask. I am currently on the Ethereum network. When I click on the right arrow, I can see the nearly $10 worth of Ether that I just transferred to an address on the Polygon network. Next, I will switch to the Polygon network. I can see an asset with the symbol WETH. This stands for Wrapped Ether and is an ERC20 compliant version of Ether minted on the Polygon network. We will learn what ERC is later in this course. Notice that while I transferred 0.006 Ether, the amount that I received on Polygon is a little less by an amount equivalent to 12 cents in dollar terms. This is what is paid to the Polygon network for providing the bridge and is separate from the gas fees paid to the Ethereum network. We will come back to this shortly. Let us step back and reflect for a minute what happened. Assume Alice has 10 $1 bills. Alice enters an amusement park and hand over the bills to the attendant at the gate, who issues her 10 tokens, each of which is worth $1. Let us call these tokens Disney dollars. Alice can use Disney dollars to buy anything that is sold within the park. As long as everything you get in the outside world is also available inside the amusement park, Alice is no worse off except that she is paying lower transaction fees. In this amusement park analogy, the sellers in the park redeem their Disney dollars for fiat dollars at the end of the day. But they may choose not to do so if they can spend the same inside the park with lower transaction fees. In this analogy, the attendant at the gate cannot double spend your fiat dollars in the outside world. This brings us to a question. What happened to my Ether on the Ethereum blockchain? To answer that question, we will switch to Etherscan. We will now view the transfer transaction in Etherscan. The transaction is initiated from my Ethereum address, the one whose private key is held in MetaMask. The destination address is a smart contract where the code for the bridging function is held. The bridge router transfers my Ether to an Ethereum contract address owned by Polygon. The Polygon smart contract in turn transfers majority of the Ether to this Ethereum contract address. The Ether gets locked in this smart contract. It cannot be spent on Ethereum, just as our amusement park attendant could not spend the fiat dollars outside. The balance amount is the small fees paid to the hop bridging service provided by Polygon. Can I see the other side of this transaction on a block explorer? In other words, is there a block explorer for Polygon? Next, we will find out. I will click on the upper right corner to access the block explorer called Polygon Scan. We can note one interesting feature. The same address is used in both Ethereum and Polygon. But that does not mean it is the same account. For instance, if the same bank account number was being used by both Citibank and JP Morgan, it would not make them the same account. The account details are a copy and paste of Ethereum. We can see that I don't hold any Matic, which is the native currency of Polygon. But I have 2 tokens held by this address. One of them is what I just received from Ethereum blockchain. The other one is a token that I do not recognize. These are called airdrops, where someone sends you a token unsolicited. Some of these airdrops could be equivalent to email spam. Others could be genuine tokens sent by a token issuer to a large number of addresses, as part of its marketing effort. We can now visualize what happens in the transfer of assets via the bridge. The asset on Ethereum transfers from the holder's Ethereum address to a Polygon contract address on the Ethereum blockchain. The asset is locked inside this address. A new token of a nearly equivalent amount is minted and transferred to the holder's Polygon address. Note that assets do not actually transfer vertically between the Ethereum blockchain on top and the Polygon blockchain on the bottom, the same way money does not physically transfer when we make a cross-border payment. To summarize, Polygon is an independent blockchain, which is designed to be interoperable with Ethereum. It allows users to transact with lower fees, with the understanding that any assets they acquire on Polygon can be transferred to Ethereum and vice versa, if they so wished. The transaction fees in Polygon are lower because it is more centralized with fewer nodes. Hence, transactions do not need to be confirmed across thousands of computers. This brings us to the concept of the blockchain trilemma as articulated by Ethereum founder Vitalik Buterin. As per his articulation, blockchains must achieve 3 outcomes: decentralization, security, and scalability. It is difficult to achieve all 3. Polygon achieves scalability but at the cost of decentralization. In theory, it is easier for node operators in Polygon to collude and break the rules of the network for personal benefit. Now that we have covered an example of an Ethereum Layer 2 solution, in the next lesson, we will do a deep dive on a Bitcoin Layer 2 solution, namely the Bitcoin Lightning Network. For now, review the summary of this lesson. See you shortly.